How to solve multi-step equations. In this video we're going to do 4 examples where we have more than one step in order to isolate our variable or get our variable by itself. Remember, our major rule here is that our equation has to be balanced, so anything I do to the left side of the equal sign must also be done to the right side of the equal sign. So let's get started. In example 1, we see that our equal sign is here, and as I bring my equal sign down, I can visually see my two separate sides here. By multi-step, we mean we're not dealing with just 2 times x or just x minus 5 anymore. We're doing more than one thing to my variable. We're taking it and we're multiplying it by 2, and we're subtracting 5 from it. We can't get rid of everything all in one step, so we have to take this in 2 steps for this example. Now, we also have to think back to order of operations, and the order of operations always told us that we would multiply or divide before we add or subtract. Since we are using inverse operations to solve an equation, that means if I am currently adding, I need to subtract. If I'm currently dividing, I need to multiply. The inverse operations means that I need to use my order of operations backwards. Okay, so long story short, when solving, you're going to add or subtract to the other side before you multiply or divide to the other side. Example 1, I'm currently multiplying x by 2 and subtracting 5. To do this properly, I have to move the 5 first because that's the subtraction. So the opposite of subtracting 5 would be to add 5. I'll do that to both sides of my equation. In the past, in a couple videos ago, we would have been done at this point because my negative 5 and my positive 5 give me a 0. But I'm not left with my x by itself anymore. I'm left with 2x. My equal sign I can bring straight down on that dotted line. 3 plus 5 is 8. I'm now left with 2 times x. That means I have to divide. The opposite of multiplying x by 2 is dividing it by 2. And again, I do that on both sides. 2 over 2 gives me my 1x, as we talked about in our multiplication and division video. That's my x equals 8 divided by 2 is 4. Box or circle it, it's my final answer. Just like we did before, I can go ahead and check this answer though as well. I have 2 times my x, which I'll use parentheses, substitute in the 4 that we just got, minus 5. Well, 2 times 4, now the correct order of operations, since I'm not solving, I'm just calculating, gives me 8. 8 minus 5 is 3, which is what we needed, so we know we are correct. Example 2. This is the only situation here where I have parentheses. Now, just like in the regular order of operations, parentheses do have to come first. So anytime I see parentheses, I have to distribute before I can add or subtract, before I can multiply or divide. It's really add, subtract, multiply, divide that gets switched in our order of operations when we are solving only. So in this case, I want to distribute my 3 to the 2x. 3 times 2x gives me 6x. Distribute my 3 to the positive 5. 3 times positive 5 gives me plus 15. Then I can bring down my equals and my 18. This part here is very similar now to example 1. I have 6 times x and I'm adding 15. First step would be to subtract 15. The opposite of adding it would be subtracting it from both sides. 6x is left here. Positive 15 and negative 15 gives me a 0. 6x plus 0 is just 6x. I'll bring my equal sign down. If I need to extend that dotted line, I can. Don't have to, but we can. 18 minus 15 is 3. I can see that I'm not done if I do extend that dotted line because I don't have x by itself. I'm currently multiplying it by 6. To get rid of the 6, I divide both sides by 6. 6 divided by 6 is my 1x, so I have my x by itself. Be careful here. We had in our multiplication and division practice problems a couple of problems like this. This is not 6 divided by 3, which would be 2. It's 3 divided by 6. I should leave that as a fraction, and I should simplify that fraction. 3 divided by 6 is 1/2. As a decimal, this one would be exact, so I suppose if you put x equals 0.5, you are still 100% correct. But be careful, your teachers might have a different opinion on whether something should be written as a decimal or as a fraction, so make sure you always defer to your teacher's rules. Either of these would be correct in my class. Okay. Now, example 3 is different. And as we find our equal sign and see that we have our two sides, we can see right off the bat what our major difference is. In every problem we've done so far, we've had our x on the left-hand side like we do here. But we also now have an x on the right-hand side. We have two terms of x, one on each side of the equal sign. That does cause a bit of a problem, but it can be fixed. We need them on the same side. Just like with solving and getting rid of plus 5 or plus 18, we do the inverse operation. We want to always, for consistency, this isn't a mathematical rule, but for consistency, move any variables that are on the right hand side, in this case the 3x, move it to the left. Just like when we were talking about adding or subtracting in the first solving video. You look at the sign in front. This is not a negative 3x. Even though I see a subtraction here, I'm going to subtract 3x from both sides because I have a positive 3x and a negative 3x. That's going to meet my goal of getting rid of 3x on the right hand side. Notice I'm doing it directly below like terms. You're going to want to make sure you stay very neat and organized when solving multi-step equations. It can get long and you can lose variables or lose problems if you're sloppy. So now I have 8x minus 3x. That gives me 5x. I haven't done anything with this 7 yet, so I just have to bring it straight down as part of my next step. The equal sign will come down the line. My 3x minus 3x got me 0, and 0 minus 3 means my negative 3 stays. So I went from two variables, one on each side, to one variable only on the left. This is what examples 1 and 2 dealt with as well. Now I can continue solving. I'm going to have to divide by 5 and subtract 7. Those are my inverse operations. I'll do the subtraction first, because when solving I always add or subtract first. Subtract it on both sides. 5x equals negative 10. Now I can do the division. Divide both sides by 5. 5 divided by 5 is my 1x equals negative 2. Done. Circle, box, highlight. I could plug this in for my x to check my answer. I'd have 8 times negative 2 plus 7. And really, I plug it into the second one as well. 3 times negative 2 minus 3. Negative 16 plus 7 is negative 9. Negative 6 minus 3 is negative 9. Those are equal, so I know this is correct. Example 4 is the last example. And this one starts with the distributive property on both sides of my equation. So I would start by distributing the 2 to give me 2x minus 16. This plus 6 is here, but I don't distribute to it. I just bring it down. On the right-hand side, I also have to distribute 5x minus 25. The key here now is I'm not going to start moving anything yet, because on the left side here, I don't have my expression here simplified. Those are like terms. Where a lot of students get mixed up is they're going to add 16, but remember, if I do that, I'm only doing that on the left side of my equation. Since these are on the same side, I combine them as like terms. And negative 16 plus 6 is a negative 10. I get 2x minus 10 equals 5x minus 25. Since they're on the same side, I don't use inverse operations. Now I have a problem that looks like example 3. I'm going to start by taking my 5x and moving it to the left. It's a positive 5x, so subtract it from both sides. If I need to extend my dotted line to see my two sides, I can do that. 2x minus 5x is negative 3x. Bring down your negative 10. Bring down your equal sign. 5x minus 5x is 0. Bring down your minus or negative 25. Still 2 steps left. I'm multiplying by negative 3, but I'm subtracting 10. Get rid of the minus 10 first by adding 10 to both sides. Negative 3x equals negative 15. And finally, divide both sides by negative 3. Make sure you remember your rules for dividing by negatives. Negative divided by negative is positive. 15 divided by 3 is 5. There's our final answer.